Hello, my name is Spot. How are you doing?
SNOW is a project at TNO for making autonomous systems safe while operating in the open world. We do that by combining knowledge and symbolic reasoning with signals and machine learning, which we'll implement it on the Spot robot. SNOW aims to increase the autonomy of systems, and increasing autonomy means to have fewer interventions. So in a particular complex environment, we want, compared to a remotely controlled system, that we have fewer interventions. Now, if we look at the history of these kind of systems, typically they operate in closed environments like greenhouses, factories, where they have repeatedly the same behavior. From that, they've started to have the systems really outside this closed environment, so walking, driving in the outside world. Boston Dynamics is one of the parties to do that. Tesla as well. There's one drawback. They can maneuver outside, but they have difficulty still to understand the world outside. Knowledge and learning are the key elements to get this understanding of these autonomous systems and make them make safer decisions. We are developing a machine intelligence that combines this knowledge with learning, so knowledge with symbolic reasoning, and the data combined with machine learning. We have two sources. The data source is coming from our systems, so it's Spot, who is moving in the outside world, giving us navigation data. We have a camera giving us visual information, and we have microphones giving us audio recordings. On the other hand, we have knowledge, such as the map of the villa that we will have our demonstration in, the objects and the victims that are in this demonstration, and also the tasks that are related to the use case, which are search and rescue. Those are part of the knowledge base of Spot. And we all combine this to have this user awareness, context awareness, and self-awareness.
I am in room, kitchen. I will exit this room via door, kitchen door.
Our aim with these challenges is to go for a system that is more general purpose, so can not only do one task in one specific environment, but is allowed to do multiple tasks in uncertain environments, and also that systems understand the real world. Another development that we used this taxonomy for was on the detection of victims. Persons are typically can be constructed out of their components. So I have a top, a middle, and a bottom. And my top is consisting of my head, my hair, my neck. My middle is related to my torso and to my hands. And if we can detect the lower level components like a head, a hair, a neck, a hand, then we might infer that there's a person.
I successfully finished operative action. Go to victim. I am going to identify human number 1. Are you Ken?
No.
Are you Emma?
Yes.
Hi Emma, good to see you.
The system should also be aware of what it can do and what it cannot do, so that it makes the right decisions. I can detect people with visual, but I can also detect people with audio recordings. And depending on the conditions, dark, smoky, or clear, I can choose one over the other. Now, if you have a system that's searching and rescuing people, there can be different preferences. So if the building is colliding, then you want that your system is as fast as possible in covering the entire building and not so much worries about assessing victims. You'll have some other people standing by, and if somebody's located, they enter the house and really rescue the person. On the other hand, you can also say, no, if my building is correct and I have time enough, but I don't have many people to help, I want my system to do the assessment. So depending on the situation, on the context, you might have different preferences as a commander of that system. The team behind SNOW consists of 15 scientists having various backgrounds. Together, we implemented state-of-the-art solutions on Spot for our search and rescue use case. Come Spot!